Hello mathematicians, here is the video for home connections 147 and 148. Okay, a review of a lot of different things. The first one says to find each product, and I know that you know that product is the answer to a multiplication problem. Anytime I see a zero, I'm always thinking, oh my gosh, there's an easier way to do this. I always just think, what's 3 times 4? That's 12. 1 in the problem, 1 in the answer. 8 times 5 is 40. 1 in the problem, 1 in the answer. 4 times 6 is 24. 2 in the problem, 2 in the answer. 6 times 5 is 30. Maybe say 2 extra in the problem, 2 extra in the answer, right? That 1 0 was part of the 30, so we need 2 zeros in addition to that. All right, next one says, show your thinking. You can use any strategy that makes sense to you. I would love for you to do traditional. Traditional is very efficient. It's the way I learned to multiply, your parents learned to multiply, and it's a great thing to kind of add to what you know about multiplication. All right, let's multiply 8 times everything on the top. 8 times 8, will you still need me? Will you still feed me when I'm 64? 8 times 7 is 56. 57, 58, 59, 60, 61, 62. Okay, next one, multiply 4 times everything on the top. 4 times 6 is 24. 4 times 3 is 12, plus 2 is 14. 4 times 1 is 4, plus 1 more is 5. And now let's multiply 5 times everything on the top. 5 times 8 is 40. 5 times 2 is 10, plus 4 is 14. 5 times 4 is 20, plus 1 is 21. 5 times 7 is 35, plus 2 more is 37. All right, cruising along. Here we go. Shade in the bars to show each fraction. It's so great having a picture that's like perfectly created and split up for you, because then it's very easy to trust your shading. All right, we've got 5/6, and we're comparing it to 2/3, and you have to ask yourself, is there more red stuff or is there more orange stuff? And there's more red stuff. So 5/6 is a bigger amount, right? More is shaded in that rectangle than the second one. All right, next one, let's shade in 4/6. And let's shade in 3/4. And ask yourself, is there more yellow stuff or is there more green stuff? And there's more green, so 3/4 is bigger. If you didn't have a beautiful picture that they had created for you, a good thing to say is, if the denominators are not the same, make them the same. And once both fractions have the same denominator, even without a picture, you can easily tell which one's bigger. Remember, we want to make things as similar as humanly possible, and then they're much easier to compare. Like letter A, already great because they both go up to the hundredths place already. So just ask yourself, what's bigger, 50 or 5? 50 is bigger. All right, for letter B, Anita, 0. Now they both go up to the hundredths. What's bigger, 29 or 30? 30 is bigger. Anita, 0. And then ask yourself, what's bigger, 60 or 63, right? If one of the numbers goes up to the hundredths place, make them both go up to the hundredths place. If one of the denominators is 100, make the other denominator 100. And if you multiply the bottom by 10, you better multiply the top by 10. What's bigger, 20 hundredths or 25 hundredths? 25. Multiply the top by 10 and the bottom by 10. So now they're both hundredths. And ask yourself, what's bigger, 89 hundredths or 90 hundredths? And what's bigger, 60 hundredths or 34 hundredths? So again, a really big concept in fractions and decimals is to make things as similar as possible, right? Make the denominators the same, make the decimals go up to the kind of that same place value. All right, let's look at page 148. Label the marked points on the decimal strip with 2 fractions and 2 decimals. All right, this first line right here, I can see that that is 2 strips out of the 10 strips in the whole thing. So 2 out of 10. Now the same thing, right? I can say it differently, but it's still the same amount. I could look, instead of how many strips, look at each individual square. And we're at the spot where there's 20 little squares out of 100. So now take those 2 fractions and just write those 2 fractions as decimals. 2/10 is 0.2. and 20 hundredths is 0.20, and those decimals are exactly the same. So all of that green stuff is the same, right? They're just different versions of the same amount. All right, the next one, 10, 20, 30, 40, 50, 60, 70. So this line puts us at 70 out of 100 little squares, or I could think 7 strips out of 10 strips. And you should know at this point in the year that 7/10 is exactly the same thing as 70 hundredths. And write it as a decimal, 7/10, 70 hundredths, and both of those decimals are the same too. So all of that blue stuff, all equivalent to each other. All right, number 6. The school lawn needs to be mowed. There are 2 sections to mow. The first one is 24 feet wide and 49 feet long. So 24 by 49. The second one is 6 by 23. 6 by 23. How many square feet of grass do they have to mow in all? All right, letter A says to write an equation to represent the problem. This is going to be a very sophisticated equation. I'm going to take the first part, and anytime you kind of want something to be grouped together, this is a very 5th grade, very algebraic thing to do. So I'm going to do the area, right, length times width of that first one, and I'm going to add it together with the area of the second one, 6 times 23. And then it says to use a letter to represent the unknown number. And a letter is a variable, and it's good to use variables when you can, just to get a bit more comfortable with them. So I think maybe for how many square feet of grass, you could use G for grass, M for mow. It doesn't matter which variable you use, but I usually try to choose one that matches the story because that seems to make more sense to the kids. All right, so letter A didn't say figure out the answer, it just said write an equation. So I'm good on letter A. Letter B says, Molly says that there are about 1,000 square feet of grass. Is Molly's estimate reasonable? Why or why not? Let's see here. Use estimation to help answer this question. I think I'm going to try to round all of the numbers. Like I think I might try to make 24, maybe into an easier to work with number, maybe even easier than this. Let's make 24 into 20. So I'm just going to estimate by making the numbers up above like a little bit easier. So 24 is pretty close to 20, and 49 is very close to 50, okay? And I'm going to add that together with, I think I'm going to leave 6, 6, and I'm going to leave 23, I'm going to make that into 20. Okay. So now let's figure this out. 2 times 5 is 10, 2 in the problem, 2 in the answer. And I've got to add that together with my estimate of that second area of grass. 6 times 2 is 12, 1, 0. And I'm wondering if I add that together, I do get 1,120. So Molly's estimate of 1,000, I think that's a great estimate. I'm going to say, yes, it is a good estimate. And I think I'm going to stop there with my answer. And let's go on and actually figure out the answer. All right, I'm going to do 24 times 49, what I did in purple, right, with like the real numbers. 24 times 49. I'm going to put the bigger number on top. 24 and 49. All right, traditional. Let's multiply 4 times everything on the top. So let's do 4 times 9 is 36. 4 times 4 is 16, 17, 18, 19. But I'm not done yet, am I? I need to, let me erase something here. I need to erase that little 3. So now I'm going to start multiplying everything on the top with the 2. But wait a minute, that's not a 2. It's really a 20. So you must always put a 0 there. I hope you pictured Elmo in that moment. All right, 2, which is really a 20, times 9 is 18. 2 times 4 is 8, plus 1 more is 9. What do we do with all this stuff? We add it together. 6 and 0, 6. 9 and 8 is 17. 9, 10, 11. All right, 1,176. Now I need to multiply the second part of my equation, kind of that purpley pink color, 6 times 23. All right, 6 times 3 is 18. 6 times 2 is 12, plus 1 more is 13. That was nice and easy, multiplying by a single digit. Okay, so now I need to add the area of that first section of grass and the area of this second section of grass. I'm going to put those two numbers together. 1,176 plus 138. And let's see. It's 11. That's 3. Nothing to carry. For a final answer of 1,314. And it's going to be square feet, right? 1,314. When I say area, you say squarea, area, squarea, area, squarea. To remind ourselves that when you are finding area, it needs to be square feet, like in this case, or square inches, or square yards, or square miles, right? All right. I think that takes us to the end. Let's take a look at the answers on 147 real quick. And the answers on 148. All right, kids, I hope you did well. I hope you feel great, and I will see you in class.